Okay, in addition to our new theorem that the intercepted arc's measure is equal to the central angle's measure, what other facts did we just use to find the missing arcs and angles? So one thing I know that we used was that the diameter cuts off 180 degrees. So we used that for a problem like this diameter right here. So these two angles would add up to 180. We also use the fact that vertical angles are congruent. So we found some vertical angles like this pair of angles right here, so we knew they were both 75. And what else might we use when it comes to circles? And I think we need to not forget that all angles added together around a circle have a sum of 360. And now that we know that intercepted arcs have the same measure as their central angle, that could also apply to all the arcs around the circle added up. So let's take this information and see if we can apply it to some other problems. All right, so assume that things that look like diameters are diameters. So number 3, we have a measure for this arc here. It's 76 plus x. And then we have a measure for this arc right here. It is 115. Now, hopefully by highlighting those arcs, you might recognize that there is a diameter cutting off those arcs. So those two arcs have a sum of 180 degrees. Just like their central angles would have a sum of 180, the arcs have a sum of 180. So we're going to set up this problem by doing 76 plus x added to 115 equals 180 degrees. All right. So if we add 115 and 76, we get 191. So x is negative 11. If I subtract 191 from both sides, I get the negative 11 from that. All right, let's look at number 4. All right, this time I have a mix of arcs and angles. And a lot of times it's helpful to either make them all arcs or make them all angles. I mostly have angles, so I'm just going to make them all angles. So for this arc that is 35x, here's the angle that intercepts that arc. So this angle is also 35x. And then I have this angle that is 35 degrees. Arc. Well, this angle right here is intercepting that arc, so we can say that angle is also 35 degrees. Now you'll notice that I have a representation for every angle all the way around the circle. And that sum is 360. So if I add 135 to 75 to 35x to 35 to 80, all of those added up together should add up to 360 degrees. All right, let me put my like terms together. So I have 135 and 75 and 35 and 80. So I have 325 plus 35x equals 360. Subtract 325, so 35x equals 35. Divide by 35, x must be 1. All right, let's go to the next one. All right, so this one I have kind of a variety of things. I could put the 74-degree angle right here because that 74-degree angle is what's intercepting the 74-degree arc. But that doesn't help me too much because I don't have measures for everything in this circle. I do have a couple of diameters, so I could check those. I have this diameter here, but I don't have measures for all 3 of these or for both of those. I have another diameter right here, and you'll notice that those 2 angles are cut off by that diameter, so they add up to 180. So my setup is going to be 126 added to x plus 60 equals 180. Turns out I didn't even need the 74. I probably could have found a way to use it, but did not need that 74. Okay, like terms, that is 186 plus x equals 180. Subtract 186, x is negative 6. All right, let's look at the last problem now. All right, so for this problem, I have a diameter. I also noticed right away that I actually have some vertical angles that might come in handy. The diameters don't help too much because we don't have something for all the angles cut off. Like these two angles are cut off, but I only know one of the measures. So if I look here, I only know 2 out of the 3 of those angle measures. I only know 1 out of the 2 of those angle measures. So the diameters aren't all that helpful. But what I do notice is that I have vertical angles right here. This angle here is vertical to this angle here. So if the angles are congruent, then the intercepted arcs are also congruent. So the 128-degree arc, is equal to these two arcs added together. So 79 added to a negative 10, so that's minus 10x minus 1. So we have 128 equals 78 minus 10x. 128 minus 78 leaves me with 50, so I have 50 equals negative 10x. Divide by negative 10, x is negative 5. And I know there were a lot of negatives for the x's. That was just a coincidence, but you always want to double check and make sure that it doesn't make any values, measurements negative, and it doesn't. Okay, that is the end of your notes. You can go ahead and get started on your practice set now.